Okay, before we continue, one thing that I mentioned or that we should have done on the last video is really just turn off the feature line. The feature line was used to create the surface. We don't really need it at this point anymore. So I would just make sure to turn off that feature line, and you might have to regenerate your screen RE and to get rid of that feature line because we don't need it. It is not part of the final construction document. Okay, so to create the drainage plan, remember that a drainage plan, an industry drainage plan has all kinds of notes and a legend and everything. I don't think we'll have time to create all this, but nonetheless, the most important thing is these calculations. So a typical drainage plan, remember, has to do with the rational formula of Q equals CIA. The rational formula, if you may remember, was something that's used, and that's kind of a universal method of calculating drainage. Q is what you're going to be calculating for. The CIA is what you're going to have to figure out how to get to. So before we get too far, let's just talk about that formula. Those are the numbers that you have to fill in on your own to be able to get a good, decent, a realistic number at least of our Q. Okay. As far as the storm frequency, it really depends on the region. Here in El Paso, a very typical storm frequency is the 100-year storm. Don't forget that we do have different storm frequencies. We have storm frequencies ranging from 2, 5, 10 year, 25, 50, 100 years. So it really depends. Unless you're told, I would probably safely go with the 100-year storm. I don't think anything else would be. I guess I'm not sure since we're making stuff up. So I would just go with the 100-year storm. So let's start looking at the C. So as far as our coefficient, this is the City of El Paso coefficient. It depends on what you're designing. If you're looking at a single family residential, you'll have a coefficient of 0.6. General commercial will be 0.95. That's more like a shopping center type of thing. So it really depends. Like in this case, we use a 0.95 because this one example is a commercial um, development. But if you're doing a subdivision, yours is not a commercial development. It actually falls under the category of a single family residential. So yours would be zero point 0.6. So let's keep that in mind. Um, and then as far as the I is the intensity. The intensity is depth over duration that you would have to calculate, and you would have to go through these numbers as far as remember that in real life, intensity is given to you by maps or charts like this one in Nashville, Tennessee, depending on the duration. So we really won't have access to that data. I'm hoping that they'll give you an intensity. If not, we'll have to kind of make one up. A intensity that's very typical here is like in the 5 range or maybe in the high 4s. So just kind of come up with a number. If you want to use 5.30, that's fine. That'll work. So we already have a zero point 0.6 for our subdivision. We have a C of zero point 0.6 and intensity of, let's call it 5.3. And then the only other thing would be the A for the area. So the area you're going to have to get. And as far as the area, usually what the way that's done is on your drainage plan, we have to draw a polyline, and that polyline will give us the area that we need, and that we take that polyline and get the area. So we're going to go over here to the surface. And in this case, it's going to be the whole subdivision. That don't forget the lots basically drain towards the roadway. The roadway is the one that's going to be draining out. So we kind of need to look at our contours. And if we look at this one's 3710 on 9876. So it looks like everything's draining 210. It looks like everything's draining 83, 93, 92, 91 to this corner. But since it's a subdivision, these lots will be draining towards the roadway. So everything to me will be draining through the roadway through here and then out the roadway here. So in this case, we can safely draw a watershed limit of the entire thing. Um, we do have some area here that would actually be kind of draining towards the lot, but I think at this point we can just kind of leave that out. So let's draw ourselves a polyline. And as far as the width, like this one here, for example, we can look at this one. This one has a polyline width of, let's see, 1.5 feet. And that's very typical of drawing the drainage limit. We'll give that one, we'll use a polyline command. We'll start from this corner here. We'll give it a width, and we'll just go with let's go with 2 for now. Let's see what that looks like. Starting and ending width of 2. And yeah, that is kind of small because this is a larger development. So let's go width. Let's change it to a width of maybe 10. There we go. I think that looks a lot better. So we'll go and draw the polyline for the entire subdivision. These corners here, this corner here. This one has an arc, so I'm just going to type in A for arc, and it's going to draw a tangent arc coming out of the end point of the last line to here. I'll fix it in a little bit and then type L for line, and then come back and draw this one up to here, and close it. You can even just click clear, close. And then I'm going to grip this guy and then grab it from here and then adjust it to here, right there. Okay. So that's going to be our drainage area limit. And once again, you always want to create your own layer. Let's go ahead and make one, and we'll call it DA limit. And as far as colors, for now, we might have to just pick one. Let's just go with maybe with the 8. And as far as line type, um, we have a hidden here. Um, Let me load a smaller one. Let me go with hidden 2. Hidden 2, just to make it a little bit smaller. So I'll use hidden 2 for my drainage area limits. And then we'll change this one over to the drainage area limit layer. DA limit. DA limit there. And there it is. Okay, you know what? That might be too small. So let's put our DA limit again. Let's change that over to hidden. It just looks too big. There we go. Yeah, I think that'll be better. And to be honest with you, I think even the width might be a little bit too much. So let's adjust the width a little bit. And again, it's just kind of judging it. It's you can change it however you need to. Maybe a 7 or something. There we go. I think that'll work pretty good. So then the next thing to do is to figure out the area. So I select the polyline, PR for properties. The area is 418610. So don't forget that the area is actually in acres. So the acres is taking the area 418610 divided by 43560. And I could have put in the full decimal places, but it's gonna give you. We're talking about a small precision here, so it'll be 9.61 acres. 43,560 is the number we need to divide by. And again, the acres should be something like this. If you get 50,000 acres, that doesn't make sense. So it'll be something like that. So that's going to be our area. So over here, we'll just have to kind of make up our own charts. You already have some text in here, so I can just maybe copy this one, and we'll call it Q equals CIA. And then we can even put where C, we can show the person, the judge, the coefficients you're using of zero point 0.6, and then we can call it residential. You don't have to do this, but it's just kind of nice to add this stuff. Your I equals, we're going to use 5.30, and then A in acres, we just calculated at 9.61 acres. Okay, so then the formula in Q equals CIA, it could be your Q would then equal that math. So it'd be the 9.61, and it's really just multiplying straight across 9.61 times 5.3 times 9.6, 0.6. So we have a Q of 30.56. Your Q will be 30.56 CFS. That's cubic feet per second. So that would be your drainage area. I would probably recommend creating like a little chart, making it look like a chart. This is kind of what we use already as far as our drainage area, drainage plan. So, short of getting all this data, that's really just what we need, the drainage area. We'll just make that chart look a little nicer. We can maybe add a little heading on it, drainage area. And we'll we should be able to put some drainage arrows, but you know what? Let's continue this on the next video.